My name is Somayyeh, and I am AD of the data science team here to talk about transfer learning and tabular data. And with me is Prateek, who is going to talk about data products at Miles. In today's demo, you're going to hear about all the techniques that we try and transfer learning and tabular data. And also we're going to talk about what is data product at Miles, building blocks, and what solution looks like versus productionization. And we're going to introduce you to some of our products, Smoky and Panorama. Transfer learning is a very popular topic in text classification and image classification. But what is the concern here that we are dealing with a type of structured data, we call it tabular data. And not a lot of research exists around tabular data. So we want to explore what are the ways for us to leverage this advanced machine learning topic, transfer learning, and being able to actually gain the knowledge we have on all of our models and being able to transfer the knowledge from one model to another model. Another reason that we want to focus on transfer learning is also we want to turn our data, which is a very high dimensional data, into some sort of meaningful representation that we call it embeddings. We want to use these embeddings to be able to actually segment our customers or simply use these embeddings as an input to our models. In more detail, the reason that we want to use transfer learning at Miles is that we have actually built a lot of models on different categories: grocery, shelf, pharmacy, liquor. We want to leverage transfer learning and unlock our data asset and being able to better predict based on the knowledge that we are gaining through this topic or domain, and or being able to profile our customer better. The other reason is that for some of the business problems we have, we require to have multiple models together. For example, how we can build a very generic open email model and just fine tune it on a campaign for offer a specific model. The other reason that is very popular in machine learning is lack of data. When we have a new customers, new products, or even new clients, how we are able to leverage the representation of the current customer at Miles and use it to be able to tag and label our unknown or new customers. And the other reason is building a faster model train. So training is always one of the challenges in machine learning, and some of our campaigns are running on a weekly or bi-weekly, and we have also training going on for hours on an optimized cluster. We want to understand and leverage some of the pre-trained models and use it to leverage and reduce the timing that we have spent on training a very problem-specific models. The techniques we tried, we categorize into three different areas. One of them is that we built some of the actually transfer learning models, such as Tabnet. We try to use SuperTML, and sometimes even we use as a pre-trained model to be able to actually label our target domain. The other technique, we leverage natural language processing, such as word2vec, GloB, or BERT, whether we train based on the type of data we have, or we also use some of the NLP pre-trained model. The third category of techniques we try was around graph-based approaches. So we came up with the representation of our customers and how they are interacting with different stores and with different products. And we use that as a sort of representation to come up with the idea of labeling our target domain. One of the technique in the category of pre-train is SuperTML. So SuperTML, actually the idea was taken from the super character where text is converted to images. So we also got the idea and we look at it, for example, on the left side, we have our tabular data at the customer level, and it's a raw data. So any sort of transactional data, how much a customer spend at different category, at a specific location, at specific timing. We look at this tabular data, we convert it to the images, and we use some of the pre-trained CNN models, and we came up with a prediction. So prediction here simply, we had the problem of scoring our customer based on the likelihood of coming to a specific store. And as you can see, one of the advantage of this super TMO is raw data. You don't need to do a lot of pre-processing before feeding this data into a before doing the conversion to the images and then feeding into the CNN. But it's still similar to any deep neural network models. We have also faced the challenges of doing the parameter tuning. The next technique is a graph-based. We try two different graph-based techniques, not-2-vec and graph neural networks. And in both graph-based techniques, we look at the interaction between customers. For not-2-vec, the interaction was around like whether a customer bought a similar item with another customer. But in graph neural network, we look at the relationship between our customer and the stores, whether they had any transaction at the specific stores. As you can see in this figure, we have the target node on the left side. So we start with looking at the target node and what is the interaction of this target node with other nodes. So simply in graph neural network, you can see how this technique is unrolling and coming up to the full coverage for all the nodes. And basically similar to neural network, it's focused on backpropagation and optimizing and minimizing the error. So one of the advantage of this technique is that for every node in the graph, we can also leverage some sort of feature representation. So we can somehow add more understanding or more features to the graph for learning. And at the end, we can also, for GNN approach, we can also come up with some encoding or a relationship between the links in the graph and coming up with a link prediction problem. And at the end, what we did with this technique, we came up with some sort of a customer embedding, and we use that customer embedding as an input for different models. One of the advantages of this technique, in addition to leveraging additional features in graph, was that the understanding and the learning or prediction with limited data was achieved compared to other techniques. The last technique category of approaches we try was natural language processing. We have product description and product category. We kind of converted this product description into tokens, where we also leverage some spending or quantity of shoppings for each category. And we did some sort of transformation to come up with our corpus. And at the end, we trained a simple word-to-vec model, or we leveraged some of the pre-trained model to come up with some sort of, customer embeddings. One of the challenges we face in NLP techniques was building the corpus. So as I mentioned, we are dealing with the various domains, whether it's the grocery or gas or liquor. So the type of domain is different. And it was very challenging to be able to aggregate all these product description together and use some of the pre-trained models. So all the techniques that we mentioned, we tried and we achieved a good performance, at least when we compared with the base model we had. So base model was the techniques that we tried, the classical machine learning approaches, and we were able to achieve 3 to 10% of improvement versus base models. But the challenges we faced was around coming up with them, embedding a different category and being able to aggregate them together. So still we were not sure like what sort of aggregation we can do based on the different categories that really had a big impact on the performance of the base model. That's it from transfer learning and tabular data, and I'll pass it to Prateek.
All right, thank you so much, Somayyeh. Hi, everyone. I'm Prateek. I'm working as the AD of data products with LoyaltyOne. And my key focus is around using different data science solutions and building products through those solutions. So today we'll be talking about data products. So what are data products? Data products are self-adapting, broadly applicable economic engines that derive their value from data and generate more data by influencing human behavior or by making inferences or predictions upon new data. To, to give you in a very short way, or to summarize this definition, data products are first of all self-adapting, meaning they learn on the go. The idea is that they learn through the data that they are predicting. They are influencing human behavior, so they are continuously learning over and over. Also, the key element here, that product, when we talk about the product, is the data. So any data which brings in value for the business and helps with the predictions using the data science model is going to be leveraged in the data products. So I'll go through the building blocks now. Let's look at how we can build a data product. So these are some of the 6 pillars of building a data product. So first of all, on the top left, defining the business problem. So any kind of product, if you're trying to build using a data science solution, the business problem has to be defined first. So there can be different types of data science solutions for different types of problems, but a product focuses on a single business problem. Maybe there are some alternate effects through the implementation of a product, like maybe if you are trying to build a product to increase a spend in a partner, it also increases some other KPIs which the partner, or let's say the client, is focusing on. But the key focus is always going to be on one key business problem that we are trying to kind of come up with. Based on the business problem, the next step is to identify the key metrics. So the key KPIs which the business is trying to optimize on are, for example, spend, engagement, maybe it could be response rate on offers, or it could be the overall incremental ROI for a given campaign. So the key metrics have to be identified in the beginning itself, because the product and the data science models inside the product will be focused on optimizing them. The next thing is building proof of concepts. So of course, any kind of new data science solution or any kind of product starts with a small POC, just to see what are the different hypotheses we have based on intuition, based on statistical past results, based on empirical data. So it could be different types of POCs we can build, and we can test different techniques as well at the same time, that, okay, maybe this technique or this algorithm works good for this particular concept, or maybe it could be a different technique for a given business problem. So building POCs helps. And once you have multiple candidates of POCs based on the KPIs and the metrics that we're trying to use for measurement, you can decide that, okay, this particular POC works best, and we can then use it for transforming it into a product, or maybe let's say a more scalable product. Once you have come up with the algorithm and you have decided on the key metrics, the next step, I would say it is a very critical step, which is called standardization of the inputs and outputs. So if you're working on a product and that product has to scale to multiple clients, that particular product itself should have standardized inputs and standardized outputs. The reason I'm saying this is because multiple different clients can have different types of data. They have different schemas of data. So you need to bring them all together, and they have to kind of transform into a way which can be fed inside the product. So let's say there are different partners that we have with Air Miles, like a grocery partner, maybe a liquor partner, maybe a banking partner. They all have different types of data. So this standardization helps us bringing all of them together to a similar set of inputs and set of outputs for that product. Now, how those product inputs and outputs are derived, or we have to transform them. It could be it should sit out of the product, and it should sit with the business users, or maybe the downstream processes who are going to use the product. Once we have done the standardization, we have a set of inputs and outputs. The next step is to orchestrate all of them together. So in a product, there are multiple systems working at the same time. It's the data science model, it's the data pipelines, it's the engine execution, the scoring training, and then it's also the downstream processes which are going to use the output of the products. So we need to orchestrate, or let's say automate, all of them together. So we need to identify the dependencies, what is dependent on what. So proper orchestration layer should be created around that, and then we go ahead and deploy the product. Now, it doesn't end here. I mean, any product which does not have a measurement layer inside its life cycle, it's not a product, because if you're not measuring a product, you cannot show the value that the product is trying to bring to the business. So the measurement is the final step, And after measurement, of course, you have to improve on the curve, but measurement is key. You can do experimentation on live market data. You can have A/B tests in there, and based on that, you can come up with the better feature upgrades in the future. So these are the key building blocks. Next, I'll talk about what is the key difference between a data science solution and a data product. Based on what we talked about right now, based on the building products, you'll understand how we are, what kind of efficiency are we trying to bring by building a data product. So if you see at the top layer, the data science solutions, they are individualized. I mean, for the same, let's say, business objective, but for different clients, we have a different model for each of them. So each model uses its own code base, own time of execution, own set of resources, even human resources. So every model is different, and it is like simply a multiplication of a same set of idea or algorithms multiplied by the number of clients this model is being used for. But at the bottom, if you see, the idea behind the data product is to bring all of those together. So the same algorithm and the engine that we have built, the data science engine, that can be leveraged by multiple clients. So we have only one data product here. We have only one code base, a same set of resources, and the execution time is just based on the number of users or the number of clients. So the maintenance is easy, the deployment is easy, the future upgrades are easy, and it's really easy to manage a data product in term as compared to like individual solutions for different clients. Going ahead, we will talk about one of a very important, or let's say a very vastly used product inside Airmiles. It's called Smoky. So Smoky is an automated intelligent marketing system, which helps us personalize offers and specifically marketing offers, and the output of the Smoky engine is for a given collector or a customer, what is the best offer. Now, it's a little different from a traditional product recommendation engine, because this engine in itself is based on a reinforcement learning technique called contextual bandits. So I hope most of the people on the call, they know about contextual bandits. But if just to kind of, if I have to explain it in a very short or a quick way, I hope everyone has once in their lifetime must have visited casinos, right? So you have different slot machines in there, and you play with different slot machines. So it's a similar idea or concept behind contextual bandits, that you have different slot machines. Based on the outcome of each slot machine, it tries and estimates the reward for the next iteration, and it gives you the best item or the idea of the best slot machine to go with. So in our case, it's the offers. So the offers are treated as slots or the bandits, and we optimize on them. Now, just looking at this whole diagram, I know it's a lot, so we'll go piece by piece. It's an architecture diagram of how the Smoky product is built. So we start from the left. So we can see the partners in yellow over there. There can be n number of partners, and they feed in inputs. The inputs are the type of offers that they're trying to kind of come up with, or they would like to set in the market, the list of the collectors, what kind of business segments these collectors lie in, and any kind of rules that the partners would like to apply on the offers, or any other business rules they would like to apply. So these all go inside the input standardization layer first. So as I said, standardization is key because the product only understands one set of schema to learn from. Now, from this input standardization layer, we come up with the different tables like the data points, like the offers, historical transactions, rules, collectors, using which we create the training set. But at the same time, this information is fed into the transfer learning engine, which creates the embeddings for the models to use. So the genome here that you're looking at, it's a combination of the transfer learning embeddings and a lot of raw features that we have created on our end. So genome is like the feature factory, I would say, which we use for building or training the models. Now, once these features and the training set goes inside the data science engine, the Smoky product, it gives you the output of the predictions for each collector and offer level. So meaning for each customer and for a given set of offers, it gives you a prediction that, okay, what is, let's say, for example, I'm using spend as a metric. What is the spend of a collector for a given offer in the upcoming campaign or a deployment period, which gets stored in a database in the table called scores. Then we have our output standardization layer, which gives you a standardized set of outputs, which then feeds into the rules or the business rules which the business wants us to put on the scores. Typically, we try and ask the business to have no rules or very less rules because they try and kind of modify the actual output of the engine. But sometimes we cannot avoid that. So we have what we have tried to do is we have kept the business rules out of the engine itself. So any kind of modification that happens should happen outside the engine. So based on the rules and the predictions, we select the final offer, which is then fed into the marketing operations team, where they take care of the communication related channels, like creating the email template, creating the mobile template, maybe on the website, and all the data then feeds into the Adobe system that we have, which is used for communication with the collectors or the customers. So we can use these offers and send them to different collectors at the same time in the same form on different channels. Now, the cycle doesn't end here. Once the offers are sent to the people, the next step is, as I said earlier, measurement. So we take care of the measurement using Looker and Snowflake, which is the data platform we're using for the measurement layer. And I'll talk about the measurement product just after this slide, but so we evaluate the performance, like the incremental spend the product is bringing in, the performance of the personalized offers as compared to random offers, and how many people we contacted, how many of them opened the email, how many of them clicked the email. So these are the different types of metrics which we capture through this. And that is how we kind of come up with the other future feature upgrades which we are thinking about the engine. So this is about the Smoky product. We have another product which I just wanted to showcase or just give you a high level idea on. So we call it Panorama, and it's also called airmiles.ai. I mean, it's part of the airmiles.ai website. So Panorama is a tool which can be used to visualize metrics, charts, any kind of KPIs. It could be internal, it could be external business KPIs, and this is all based on Looker. So Looker is like the BI platform that we use for visualizations and measurement. So as you can see on the side of the screen, we have these Smoky results for one of the campaigns over here. So we look at the targeted collectors, how many people we contacted, how many of them responded, what does the ROI look like. And the good thing about this particular platform is you can actually play with the charts in there, right there and then and there. If you want to modify some data or run some SQL queries, you can do that inside this engine itself. So it's at the end of the day, what I wanted to show here was that any data product without performance evaluation and measurement of the business metrics is not a complete product. So that is key to building a data product. And it should be all automated, and it should be integrated with the response data. So yeah, so this is all from my side as well. I just wanted to show how the two products are working together and how Airmiles is using different machine learning techniques to build data products in the longer term. And we have a lot of different ideas that are also going to come in. We have many other products. I think there is one other talk done by Maxine from from Airmiles. It's around product recommendation engine. So please join that if you haven't done already. So go ahead and enjoy the sessions. Thank you so much.